Hello friends. I don't know what should I tell. In India it is good evening. In USA it is good morning. Uh, by now I hope you have started knowing me because some 60, 70 videos are put up and we are running two subjects parallel now, transmission line protection and the uh, engineering, procurement and commissioning of 66 by 11 kV substation. Third subject, thermal power generation also will come. So one by one these subjects will come. Roughly 150 to 200 videos will be placed on YouTube. And you are going to get a knowledge free of cost. So today we are going to talk on transmission line protection, session 13. And only last session 14 is remnant. That probably tomorrow will come and tomorrow we'll talk on that. That will complete transmission line protection using overcurrent and earth fault relays. Transmission line protection using distance relays we have completed. Transmission line protection using line differential relays also we have completed. Generator protection we have completed. Transformer protection, 3 videos are yet to remain. 1, 2, 3 is complete. 4, 5, 6 will come. And then I will go to induction motor protection and will then go to bus zone protection, which will be shorter one. And lastly, protective current and potential transformer, which will complete power system protection as a whole. The engineering, procurement and commissioning will run for about 20 sessions of half an hour each. Or it will not take half an hour, it will take 1 hour because it took 20 hours when I was talking with my students at Nirma. Because they took interest, they wanted to know how the substation can be engineered. So the material was ready with me. Power plant, we have written a book. That is not, that kind of book is not available anywhere in India. In foreign countries, CEGB, that is Central Electricity Generating Board, prepared the literature for training their engineers. There were 4 volumes at some time, and they were training. But the material was so rich that the publishers, international publishers started taking interest. So CEGB floated the tenders and they gave the order to the person who would pay the most. So Peter Peregrinus could get the chance. He published 4 volumes. Then he published 8 volumes. Out of 8, at least 3 I have read completely. Each volume of 500 pages each. So 8 volume means 4,000 pages are written. Out of 8, 3 volumes I have read. There are many mechanical things also because power plant actually electrical is only final thing, generator. All other things are mechanical. So you cannot say that I do not want to understand mechanical. Okay, you cannot design boiler feed pump. Okay, you cannot repair boiler feed pump. But there is something wrong with boiler feed pump that you should be able to tell. So that those 8 volumes are there, and finally now I have heard that now they have come out with 15 volumes. Same thing. Those 15 volumes I want to purchase, but it was costing 1 lakh rupees, and I told my principal at BVM. He told librarian. Librarian said that this is out of our budget. So finally I could not. Then personally, I wanted to purchase some time, but then now, as the age is increasing, my I mean to purchase, I mean to spend 1 lakh rupees is nothing, but to read 15 volumes and then I mean, I cannot write all 15 volumes. There is no use. I have to make it short to some 100 pages or 200 pages, and then I can give to people. So that such an important thing, because you see what people are teaching. Thermal power plant means what? Coal is burnt, water is converted to steam, steam runs steam turbine, and generator runs. That is not thermal power plant. Thermal power plant, in one control room, there are 9 people in one shift, 27 people in 3 shifts. There are about 1,000 people working day and night. Thermal power plant is a big business. People, the students and faculty do not know this. Faculty teaches from the books. They do not go to industry, right? So the thing is like that. Anyway, right now, transmission line protection, session 30. So if I talk of session 13, my dear friends, uh, same figure, which we talked on session 12. But at that time, we were setting relay R1, R2, R3, R4 phase relays. Now we will set earth fault relays, and you will find that it is going to be difficult. F1, F2 fault currents are given, earth faults. Now the earth faults I will have to give. System is the same, 1500 bar 1 ratio on one side, 1000 bar 1 ratio on the other side. One side 3 generators, the other side 2 generators. 15.75 by 220 kV, 210 megawatt, 0.85 PF. Loads are given. Everything same. But the load currents will differ. Fault currents for loads I have used for LG faults, that you have to remember. Last time we used for LL faults. Now you see, when CT1 fault occurs at F1, maximum current flows there. At other points, less current flows. And when fault occurs at point number 4, F2, then CT4 maximum current flows, and at other points less. So now if you go further, calculation of plug setting, R1 to R4. Now there is no final relay, last relay koi hai nahi. So we start with some relay. So we start with plug setting of ground rail is R1 and R4 as 10%. Just like that only. I'm just guessing. You see, discriminatory. I have no ground to decide anything. But list I'm deciding. List means the relay will operate as fast as possible. That I'm taking care, because 10 to 40% is the setting. I'm deciding 10%, the list. Now fault occurs near R1. So TMS of R1 I am assuming 0.1. You can assume 0.05 also. 0.05 is available in traditional relays also. But in electromagnetic relays also less than 0.05 is not available. Right? So even if it is numerical relay, it is in steps of 0.05, that is 0.05, 1, 1.5, 1.5 to 2.5, like that. But the traditional relays give 0.1 to 1. These relays give 0.1 to 15 numerical relays. So I mean, that way the things differ. And then there are many facilities, and to configure the relay becomes very difficult, right? And you have to use those relays only. So later or earlier you will have to learn those relays. But I've been to 2 big colleges, first 2 colleges, Nirma and PDPU. No student is ready to understand. No faculty is ready to work. I am very much annoyed. In BVM, we were working day and night. Birla Vishwakarma Mahavidyalaya, the first engineering college in Gujarat state, established in 1948. We were working like anything. But now, nobody is ready to work. Reasons, I don't know. Many reasons. Because now government because people are not working, government has to I mean, decide the rules. They say that क्या बोलते हैं अभी आजकल कि you have to get कोई सर्टिफिकेट है वो accreditation certificate, then you have to go for NIRF, that means which is your rank. So in these things, teaching and learning are forgotten. So students are doing events, they're enjoying the events, football, volleyball, this, that. So teaching is not done. In humor, I tell that in railway, one comb seller was there and he was selling the combs. He told that, see my comb is straight. He turned it round, made it circle. So see, comb is not uh, breaking even after making it circle. Then it threw. So after throwing also, it does not break. Then he had a lighter in his pocket because he was smoking. So using lighter, he burned the that comb. Comb did not burn also. So somebody asked that can I comb my hair? ठीक है, it does not break, but can I comb my hair? That comb seller told, oh, I am sorry, you cannot comb your hair. So in engineering institutes, NIF ranking number 7, NEC accreditation A plus, and uh, you are accredited. Electrical, mechanical, civil department accredited. College is working very fine. Our faculties have 14 PhDs and many PhD holders have 100 papers on their hand. But are you teaching? Oh, no, sorry, we are not teaching. Teaching learning process is not there. So in that environment we are living, environment will still worsen. But how the world will run, that only God knows. I do not know. But I am trying my level best. I am knowing power system protection and other two subjects I told. I am giving it on this. So I am assuming TMS of R1 as 0.1. R1 is not last relay. Any one relay I have to take. You can take R2 also. Fault current there is 7933 amperes. For 7933 amperes, equivalent secondary current divided by 1500 gives me 5.28 minus 0.09, right? Minus 0.09. Sorry, minus 0.15. 0.05 is the excitation current. So minus 0.15, 3 times 0.05. So that gives me 5.13. 5.13 divided by 0.1 plug setting 51.3 I cannot take. So time of operation is 3 upon log 10 20 into 0.1, which I assume is 0.23 second. So R4, which is going to give backup, right? The time of that will be 0.25 second higher. But for that R4, I have to find out PSM. So there the current flowing is 1633 for the same fault current. See, for the same fault current F4, F1, current flowing is, sorry, F2, the current flowing is 2088. So 2088, sorry, 1633. I'm talking about F1 yet. So 1633 is flowing. So 1633 divided by 1000 minus 0.15, that is excitation current, minus upon 0.1, that is plug setting 14.83. Yes, well, I can take. And TMS of R4 is 0.48 into log 10 13.83 upon 3. So TMS that is available to me is for R4 0.48. So 0.48 means I have to take 0.5. So if I take 0.5, then for that 0.5, again I have to calculate PSM of R4 because R1 should give backup to R4. So R4, the PSM is 1483, TMS becomes, sorry, uh, TMS R4 is 0.2, 0.2 is accurate. Now PSM of R4 is 6059 for another fault. So for that, the PSM is 59.09. So I cannot take, I have to take 20. So top of R4 is 0.4611. TMS 0.1, I cannot, sorry, hence 0.2 is selected. 0.2 I cannot change. And PSM of R1 is 12.42. Top is 0.274. So R1 operates earlier than R4. That is wrong. R1 should operate 0.25 seconds later. So this setting has gone wrong. First iteration have failed. So I have to go for second iteration. I have to go for third iteration. I have done that manually. So many iterations if I do here, you will be tired. So final iteration in which I have been successful is R1. Finally, what I have to do, if TMS of R1 is adjusted at 0.85 and TMS of R4 at 0.9, plug setting both 10%, then top of R1 is 1.9599 and top of R4 is 2.3. 0.34 and for faulted F2 2.075 and 2.33, so 0.255. So that discrimination margin. So my final setting is R1, R4 and R1 is R2, R3 is R4. So 0.85 and 0.9 that I could come at. But see, things are yet very complex. Had I been for PSM R1, R2 at 15% and R3 and R4 at 10%, if I would have done that, then the discrimination margin would have also been maintained and relays would have operated faster. The relay operates faster by 0.8 seconds. In protection, if the relay operates faster, that is better. So second trial I have made is R1, R2 plug setting I have changed. I can yet go for third iteration, fourth iteration, and I may gain correct discrimination margin and yet relays may operate faster. So interconnected system becomes very complex and therefore relay setting is very complex and therefore distance protection is used. That is what I wanted to tell you. In plug setting, at first iteration, we succeeded. Here, we did not succeed at first iteration. We had to do 10, 15 iterations, which are not shown here. I have shown only final in which I have succeeded. But things are yet whatever I have done is not final. Yet better thing is possible. Yet better thing is possible. You have to try. And for that, you have to formulate an algorithm and then optimize the relay setting. People are doing. One of our students at PDPU optimized the setting for 7-bus system. And then the final viva was there of PhD. It was PhD. So examiner like me asked him that is all you are optimizing, minimum time of operation you are gaining at. But what is the meaning of plug setting? That I don't know. Person has become PhD and I'm asking him what is 1 plus 1. Oh, sorry. Sir, I am PhD plus 1 plus 1. I have forgotten. The time is that we are living in educational time where people use calculator 2 by 2 is equal to 4. I had seen one video, I had seen one, WhatsApp message in which he was showing the advancement of technology. Technology is so much advanced that now you see for going from one place to other, you are using map, no? Google map. So A boy was using a Google map for going from his drawing room to bathroom. So Google map is required for going from drawing room to bathroom. We have reached at that technology level. We have reached that technology level. And I am facing such difficulties. I am 72 years old. Today's generation is different. Therefore, there is a generation gap. People do not want to understand. I don't know how many of you would like to understand these things, right? But these are final things in our system protection. I mean, this is what most complicated thing I have done to you. So this is just the summary of settings. Now we will see the specifications. If you want to purchase overcurrent or earth fault relays from market, what you will ask for. What is to be asked for is written, and on the right hand side, what is usually available in field, that is also written. You will first ask rated current, 1 ampere or 5 ampere. Some relay manufacturers give 1 ampere or 5 ampere, and some relay manufacturers give 1 ampere and 5 ampere, both. Whatever you want to use, you can use. Thermal withstand capacity. Continuous thermal withstand capacity of all numerical relays is 400% of rated current. That means its rating is 1 ampere, 4 ampere it can withstand for 365 days and 24 hours. Thermal withstand. But for 1 second, it can withstand 100 times. That means 100 ampere it can withstand for 1 second. Dynamic current withstand, that is half wave value. Up to half wave, 10 millisecond, 250 times the rated current it can withstand. Yes, this 250 can vary from manufacturer to manufacturer. This is just from one manufacturer I have taken. But mainly you have to ask for dynamic current withstand. Burden 50 millivolt ampere. Rated frequency 50 or 60, because in foreign countries 60 is going. Setting ranges. Flux setting, sensitivity threshold, or start value or pickup value. Flux setting. Phase over current relays 0.05 to 5. You see, we were talking 50% to 200%. This is 50% to 5%, and that too in steps of 0.01. I'll start speaking. If I start speaking now, I'll finish tomorrow morning. 0.05, 0.06, 0.07, 0.08, 0.09, up to 5. It will be morning tomorrow. Ground over current relays 0.01 to 5 times IN in steps of 0.005. Then there is I double greater than 0.1 to 40 times IN. IN means rated current in steps of 0.01. And I triple greater than 1 to 40 times IN in steps of 0.01. Start value multiplier. This is a very important function. Once I've explained that when you energize the transformer, it takes 10 times the current, but it is normal current. Transformer is not damaged. But if there is an internal fault, it can be 5 times, and then transformer very badly damaged. So your high set setting has to be more than 10, because 10 times is the if your 100 ampere is your transformer primary current and 100 bar 1 CT is there, then 10 times means on secondary side 10 ampere. So your high set setting has to be more than 10. But then for that 5 ampere, 500 ampere, it will not operate. It will operate after time delay. And within that time, the transformer will just blast. So numerical relay manufacturer gives start value multiplier. It sees this starting current, because 10 times the current is not sinusoidal. It is highly distorted. So it reads the DC value, it reads the subharmonic, it reads the superharmonics, and based on it, it decides that this is a magnetizing inrush. So when it is magnetizing inrush, start value, say if you have set at 5 ampere, it will be multiplied by 0.8 to 10 times, whatever you want. Say 3 times, so it will be 15. So relay will not operate. But if it is fault, then it will not be, because start value means 0 to 10 times. But fault is 1 time to 5 times. So relay will not, start value multiplier will not act and relay will operate. EMS is 0.05 to 15 as against 0.05 to 1 in steps of 0.05. So these are the setting ranges. Operate delay time. Operate delay time. This is only for definite time overcurrent relay, 40 milliseconds to 200 seconds in steps of 10 milliseconds. This is only for definite time units. Operating current curve types. How many curve types it is giving you? Normal inverse, very inverse, extremely inverse, moderately inverse, definite time, long time inverse, programmable characteristics, rarely inverse, RX IDG curve, and I squared T equal to constant. That curve. So many curves. Single relay is giving. You have to select, no doubt, one at a time. Some of these curves are as per IEC, some are as per NC, and some are as per IEEE. Because for different standard, there are some variations in the formula of time of operation. So totally 17 or more curves are given by a single relay, costing about 1,30,000. Overcurrent relay. Induction motor relay is about 1.75 lakhs. Generator relay is roughly 2 lakhs. Very costly, but giving many facilities. And because of that, you see, it gives you the distance to fault. The fault is at 80 kilometers away. You run the zip car at 80 kilometers per hour, reach there, and within an hour you clear the fault. Power system will be available for more time, and if it will be available for more time, people will use it. On the consumer side, people are losing production. So they are also at loss. And on electricity board side, they are losing revenue. So both will be better. Power system will be better available. The possibility of instability of power system will be less. You see, so many advantages are there. Not only that, between two relays, you are keeping 0.25 millisecond time interval. That is the discrimination time margin. That can be reduced to 0.04 second. Many advantages. Many advantages are there. Probably we are going to talk in the next 14th class the different advantages of overcurrent relays. I mean numerical overcurrent and earth fault relays. Resetting time is 0 to 60 seconds in steps of 1 millisecond. Resetting is also in your power. Definite minimum time. You see, relays have definite minimum time. In older relays, traditional relays, it was only 2.3 second at TMS1. You cannot set it. Here, you can set it 20 millisecond to 60 second, whatever you like. Minimum definite time, that minimum definite time is settable, right? Accuracy class 7.5 as per IS 3231. Setting ranges of directional unit, characteristic angle -179 degree to +180 degree in steps of 1 degree. Very nice. Polarizing quantity. Usually we use cross polarization, that is IR and VYB, etc. Output contact rating, binary outputs. There are 16 binary outputs in the numerical list, some of which are power outputs and some of which are signal outputs. Signal outputs, the setting will be less. Tripping contacts, rated voltage 250 volt, continuous carry 5 ampere, make and carry for 3 seconds, braking capacity, contact material, AgCDO2, signaling contacts. That was for power contacts, tripping contacts. This is signaling contacts. Everything is given for the contacts. This is binary outputs. Then there are binary inputs. Usually nowadays people give 16 binary inputs, but the functions of binary inputs are probably 50 or so. So you cannot use all the functions. Whatever functions you need, you have to configure. So binary inputs means 110-volt DC is to be given to particular contact, and if you give that, certain things will happen. That means either the set, there are 6 sets in our current relay. Either set will change, either relay will block, some protection function will block, right? The relay will be uh, locked out type relay. That means even if the current goes to zero, relay will not reset. Self reset will not be there. Hand reset will be there. So many functions are available using binary inputs. Power supply for binary inputs is 80 to 265 volt AC/DC. So these are the specification. Tests. You have to do tests. Whenever you order, you will have to say that I would want to see so many tests. It's quite possible that you may say that I will see only these certificates. That's all. But you say that no, I want to witness the test. So tests are what? Power frequency over voltage test. All contacts, live contacts of relay shorted together and earthing, one earthing terminal is there. Between them, 2 kV is given for 1 minute. Relay should not be damaged. Impulse withstand 1.2 by 50 microsecond, 5 kV. Relay should not be damaged. Insulation resistance more than 100 megohms. Disturbance test, high frequency interference test, electrostatic discharge test, electromagnetic field test, mechanical test, seismic test, vibration test. You have to uh, uh, deliberately vibrate and see that relay is not. Shock test. Shock test means relay is kept and one hammer is there, 100-gram hammer is kept vertical, and then from vertical it is dropped and it will strike on the relay. The relay should not be damaged. That shock test I have done for meters. You see, all these tests, if you see yourself, then you will be master of things. But unfortunately, colleges are not teaching. Colleges are not teaching, and students are not learning. Students are they are thinking something else. More or less like corpses. Corpses sitting on the bench and teacher speaks in air. So I am very much disturbed with uh, the method in which teaching learning process is going on in Nirma and PDPU also. Very big colleges in Gujarat state. That is the condition. But unfortunately, I cannot speak anything because one person cannot do anything. I'm doing this alone. Whosoever is interested can come with me and can learn. And you will see that you will be much better than others. Will be much better than others. I am much better than others. I am invited in institutes. I am never applying. I have applied only once when I was 25 years old, because at that time I had to serve. So in BBM Engineering College and other places I had applied. But after retirement, I have never applied. People are calling me. Transport and storage temperature minus 42 plus 700. Enclosure protection. Enclosure protection is required. You see, enclosure protection means relay is kept in a very bad environment, very high temperature, very low temperature. There will be dust. There will be conducting powders deliberately. That IP54 is the worst environmental standard and relays to pass that. All these tests you can witness. You can ask to witness. At ERDA, Electrical Research and Development Association, all these tests are done. You can visit and you can see these tests being done. With this, my friend, I come to an end of today's lecture. I request you to stay tuned with Head Up Me. If you do not want to be a part of students and teachers of this generation, and if you want to learn really high technological standards, please remain with Head Up Me. Head Up Me is trying level best to do that. So let the name of Head Up Me rise in the sky, up in the sky. Let all electrical engineers who are interested in power systems know Head Up Me. I have reached only up to 1200 watch hours. I am really very sorry. I feel very sorry that such a rich material, 4000 watch hours, is the first milestone in YouTube that I should have reached within a month or two, which I am not reaching within a year also. I have started advertisement also. I have started giving advertisement. I will yet give advertisement. I am ready to spend about 50,000 rupees for advertisement, but want to see that knowledge is reached right quality, high quality knowledge goes to the persons who are in industry, persons who are in academics, and they teach that high quality to students so that the new generation students will, because the technology as well is advancing very fast. And yet today, electromagnetic disk type relay is being used. So that should not be the case. So please stay tuned with Head Up Me. In YouTube, you have to search Head Up Me, EDUPME, and you will see all the videos. There are around 80 videos of different subjects, not only my subjects, but different subjects. And you will learn a lot many things free of cost. Thank you, my friends, and good day.